Welcome! In this video, we will explain the functionality of the ELCO AppDesigner and the App Hub. For better visualization, we will design an app that reads sensor data from an imaginary factory building and controls the corresponding ventilation. To guarantee that you can follow our video, we assume a basic understanding of the IoT Hub, including the related terms, things, and properties. We start in the IoT Hub web interface, where we have already created a thing. It represents our factory building and includes three different properties: sensor values for temperature and humidity, as well as the current speed of the ventilation. Our app's task is to visualize sensor data and the current status of the ventilation system. Furthermore, it's supposed to provide additional control elements for controlling the ventilation. The user interface will later look like this. The App Designer can be accessed via the navigation bar of the IoT Hub. As soon as we have logged into the App Designer, we find ourselves on the homepage. Here we can either select an existing app or create a new one. All we have to do is to enter a name and click on the button. Afterwards, we get to the editing mode for our app. This is divided into three areas: the Widget Tree on the left side, the Widget Editor in the center, and on the right side a preview of the app. The Widget Tree contains a tree-structured list of all UI and layout elements of our app. Since we have not yet added any, there is currently only a text node there. If we now create and select a widget, we can edit it in the Widget Editor. The app preview shows us the user interface of the app in real time. Also, there is a menu on the left-hand side of the screen that allows accessing important functions such as displaying the app's QR code, deleting the app, adding media and general app settings. We will first open these settings to upload a preview image, which will later be visible in the overview of the App Hub. To do so, we select an image using the input field and click on the upload icon. As soon as the image appears at the bottom, we can close the dialog again and start with the actual creation of the user interface. First of all, we have to select a root layout widget for our app. Layout widgets serve merely as containers for other widgets. The App Designer distinguishes between the layout widgets row and column. The elements within them are arranged horizontally in the row layout or vertically in the column layout. Because of the portrait smartphone display, the columns layout is suitable as a root layout widget. Once we have selected the layout, it is added to the widget tree and automatically selected. This causes various input masks to appear in the widget editor, which can be used to configure the widget. We can assign a title and an inner spacing or padding for all widgets. For layout widgets, we can also specify how the elements within them should be arranged on the horizontal and vertical axes. In this case, we specify that the elements should be arranged on the vertical axis, beginning at the start of the layout. On the horizontal axis, we select the value stretch. This ensures that the widgets in this layout widget always take up the full width. The next element we want to integrate into the app is the status information for ventilation. This should be represented by an image for ventilation on or ventilation off, a text with the current speed, and a horizontal box visualization. To group these semantically related elements, we will again use a column layout widget. We can add this via the plus button next to the root widget. For the horizontal alignment, we choose the centered variant this time. For all other values, the default configuration is sufficient. Now it is time to add the actual status elements. To do this, we add an image widget to the column widget we just created. For the image, we assign a width and a height. To select an appropriate image, we first have to upload image files via the Media Manager. The Media Manager can be reached via the menu bar on the left, as already mentioned. Here we add a picture for each of the two states, ventilation on and ventilation off, and assign appropriate titles. Afterwards, we can select an image in the widget editor. To exchange the image automatically, depending on the state of the ventilation, we add an image visualization. Here we can then select our factory in the Things selection menu and then the property for the current speed of the ventilation. Since we have specified the default image for the state ventilation off, we now have to define under which condition the image should be replaced by the one for ventilation on. This is the case when the selected property has a value greater than 0. Therefore, we select greater than as the comparison operator and specify 0 as the comparison value. Finally, we select the graphic for the state ventilation on as the visualization image. Now it is time for the text showing the current speed. For this purpose, we add a text widget. We first define a default value which will be displayed if no data from the IoT Hub is available. We also select a centered alignment of the text. Now we add a text visualization to dynamically link the text to the current speed. Here we select the corresponding thing and property again and also specify a unit, in this case revolutions per minute. That's it. In the next step, we can now focus on the box visualization. To do this, we add a new child element, in this case a box widget, to the layout widget as before. Here we select a color for the foreground and background, and then specify the dimensions for the box. So far, the box is static and not linked to any data. To change this, we add a box visualization. Again, we select the corresponding thing and property. Afterwards, we have to specify the minimum and maximum value. Additionally, we define the visualization direction from left to right. We have now added all three desired widgets for the ventilation state and got to know the widget types image, text and box. Now we want to display the sensor data for temperature and humidity side by side. As mentioned at the beginning, a row layout widget is suitable for this. We will add one to the root layout widget. Here we have to make sure that we actually select the correct parent layout widget. The sensor data is not part of the ventilation state, so we add it one level higher to the root element. In this case, we set the horizontal alignment to space evenly, which will center the elements with even spacing on both sides. Because we want to display a label below each of the two values, they need to be added to a column layout widget. Therefore, we first add two column widgets to the row widget. We then add two text widgets to each of them, whereby the upper one receives a text visualization that is linked to the respective property for temperature and humidity. The text widgets at the bottom of each column are given a static name. Using padding values, we can also add some spacing between the widgets. Next, we want to add elements for controlling the ventilation to the app. Since they are semantically independent from the sensor data, we add a new layout widget to the root element. Then we first add a heading in the form of a text widget. In the next step, we want to display 3 buttons for selecting the ventilation speed next to each other. Because we want to display the buttons next to each other, we add a row widget as their container. To ensure that the buttons are evenly distributed, we select Space Evenly for the horizontal alignment. Then we add 3 button widgets and label them with the corresponding names using the widget editor. In the current state, however, the buttons are still without any functionality. To change this, we have to add an action to each of them. Similar to the visualizations before, we then select the thing and property that should be changed by clicking the button. In this case, the ventilation speed should be set to the specified values. In the last step, we want to give the user of the app the possibility to define the ventilation speed manually. This is possible by adding a value input widget. Similar to a button, this allows to assign a value to a property. However, in this case, users can enter an individually defined value. In addition to the typical widget attributes, we can also define a hint text. Our app is now complete. To save it, we click the corresponding button in the sidebar. To avoid possible data loss, this should be done regularly, especially when creating more complex apps. To get a rough feeling for the usage of the app, we can also simulate its functionality by clicking the Play button in the preview. This helps to get a better idea of the app, especially during the design process. However, this is only simulated data that is neither read from nor sent to the IoT Hub. But now that we have an already finished version, the time has come to try out our app on a smartphone in the App Hub. All we have to do is display the QR code for the app in the sidebar and scan it in using the App Hub. To do this, we open the App Hub on a smartphone and select the QR code scanner. After scanning the code, we might have to log in. Afterwards, we will find our newly designed app in the app overview and can use it.